Hello everyone, welcome back to my channel. Today we are going to solve 48 questions from GATE 2022. We are given y is equal to alpha minus 1 transpose where alpha is a real number, and this is a feasible solution for the dual problem of this given linear programming problem. So note that y is not solution to this problem, it is solution to dual of this problem. So from this information we have to find out which of these statements is true, and all these statements contain alpha and some bounds on alpha. So first let us form dual problem of this LPP. Okay, so this is let's write given problem first. This is maximize zx is equal to 5x1 plus 12x2 subject to constraints x1 plus twice x2 plus x3 is equal 10, twice x1 minus x2 plus 3x3 is equal to 8, and x1, x2, x3, all three of them are non-negative. Now this is our primal problem. We have to construct dual from this. How are we gonna do that is, this is maximum, so in dual it will be minimum. Now they have used x variable here, so we will use y. Minimum zy is equal to. Now the coefficients of yi's will come from here, 10 and 8. So it will be 10y1 plus 8y2. So the number of constraints in primal is equal to number of variables in dual, right? Okay, now the constraints. Let us form the constraints now. So basically we have to take transpose of the constraint matrix. So now if the constraint matrix is in first column, we write coefficients of x1, second column is coefficients of x2, and third is that of x3. So take transpose of this, and this is into x1, x2, x3, right? So take a transpose, we get 1 minus 2 1. So here we had only two constraints now, but in dual we are gonna get three constraints, 2 minus 1 3, and the variables y1 y2. Now multiply this, we get subject to y1 plus twice y2. Let us write right hand side afterwards. Second is minus twice y1 minus y2, and third is y1 plus thrice y2. When we were finding coefficients in the objective function in dual, we used RHS of the constraints of primal. Likewise, if we want to find out RHS, we will use coefficients in the objective function from primal problem. So in minimum the constraints will be greater equal type, right? So this is 5, the second will be 12, and since there is no x3, we will take it at 0x3, so 0. Now the sign of y1 y2 doesn't really matter here, so we will not go into that. If they are positive or they have unrestricted sign, we just have to find out some bounds on alpha. Okay, now that we have a dual problem and we have its feasible solution, we will just put this solution into these constraints because it is a feasible solution, so it will satisfy all the constraints, right? Now the first constraint is y1 plus 2 twice y2 greater equal 5. So we will put y1 is equal to alpha and y2 is equal to minus 1 in all the constraints, right? So first constraint becomes alpha minus 2 greater equal 5. This implies alpha greater equal 7. The second is minus twice alpha plus 1 greater equal 12, implies minus twice alpha greater equal 11, implies alpha less equal 5.5. So it will be alpha less equal minus 5.5. I think I messed up something here. Okay, so in this coefficient matrix we had 1 minus 2 minus 1. Okay, we don't have minus twice x2 here, we have plus, so this will be plus. So here plus 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 twice y1, therefore okay, so we get this implies alpha greater equal 5.5. Until now we have got two conditions on alpha. Now the last constraint, alpha minus 3 greater equal 0, this implies alpha greater equal 3. We have three conditions on alpha. So if alpha is greater equal 3, if alpha is 4, then it satisfies this but doesn't satisfy these two. If alpha is greater equal 5.5 but less than 7, suppose alpha equal to 6, then it satisfies this but not this. So we must have alpha greater equal 7. If alpha is greater equal 7, then it will be strictly greater than 5.5 and it will be strictly greater than 3 as well. Therefore, the condition is alpha greater equal 7. So let's check if we have that option. Okay, so this option is the correct option. Alpha greater equal 7. Okay, so I hope you all understood this solution. See you in the next video. Thank you.